In this problem, you will identify functions using mapping diagrams. Part A. Identify the domain and range of the relation. Represent the relation with a mapping diagram. Is the relation a function? When is a relation not a function? A function maps each domain value to exactly one range value. So, a relation that maps a domain value to more than one range value cannot be a function. The domain contains the x coordinates. The domain is -2, 0, 4, 5. The range contains the y coordinates. The range is 5/10, 2 5/10, 6 5/10. Represent the relation with a mapping diagram by mapping values in the domain to values in the range. Represent each ordered pair with an arrow in the mapping diagram. -2 maps to 5/10. 0 maps to 2 5/10. 4 maps to 6 5/10. And 5 also maps to 2 5/10. Each domain value is mapped to only one range value, so the relation is a function. Notice that a relation can map two domain values to the same range value and still be a function. Part B. Identify the domain and range of the relation. Represent the relation with a mapping diagram. Is the relation a function? The domain contains the x coordinates. The domain is 4, 5, 6. The range contains the y coordinates. The range is 3, 4, 5, 8. Represent each ordered pair with an arrow in the mapping diagram. 6 maps to 5. 4 maps to 3. 6 maps to 4. And 5 maps to 8. Remember, a relation cannot be a function if it maps a domain value to more than one range value. The domain value 6 is mapped to two range values, so the relation is not a function. Now it's your turn. In this problem, you will identify functions using the vertical line test. Part A. Is the relation a function? Use the vertical line test. First, graph each point. Use a pencil as a vertical line. Place the pencil parallel to the y-axis and slide it across the graph. See if the pencil intersects more than one point at any time. The domain value 1 corresponds to a single range value 2. The domain value 0 corresponds to a single range value, -2. The domain value -3 corresponds to a single range value, 1. The domain value -4 corresponds to two range values, 2 and -1. The relation is not a function because for one domain value, there is more than one range value. Part B. Is the relation y equals -x squared plus 3 a function? Use the vertical line test. First, graph the relation. Use the vertical line test to test a couple of points. The domain value 1 corresponds to a single range value, 2. The domain value -1 and 1/2 corresponds to a single range value, 3/4. There is no vertical line that passes through more than one point of the graph. So, the relation is a function. Now it's your turn. In this problem, you will identify a reasonable domain and range. You have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet. The function a of q equals 100 times q represents the area, a of q, in square feet, that q, quarts of paint, cover. What domain and range are reasonable for the function? What is a graph of the function? What do you know? You know that 1 quart of paint covers 100 square feet. You also know that you have 3 quarts of paint to use. What do you need? You need reasonable domain and range values in order to graph the function. So what's your plan? Find the least and greatest amounts of paint you can use and areas of trim you can cover. Use these values to make a graph. The least amount of paint you can use is none, so the least domain value is 0. You have only 3 quarts of paint, so the most you can use is 3 quarts, so the greatest domain value is 3. Therefore, the domain of 0 is less than or equal to q, which is less than or equal to 3. To find the range, evaluate the function using the least and greatest domain values. Zero quarts of paint covers 0 square feet of trim. And 3 quarts of paint cover 300 square feet of trim. If you use between 0 and 3 quarts of paint, the range of trim covered is between A of 0 and A of 3 square feet. So the range is 0 is less than or equal to A of Q, which is less than or equal to 300. To graph the function, make a table of values. Choose values of Q that are in the domain of the function. These integer values are in the domain of the function. Find A of Q for each value of Q in the table of values. Now graph the function. Plot each point from the table of values. The graph is a line segment that extends from the point 0, 0 to the point 3, 300. Now it's your turn.